Hi everybody. Getting back to this Nintendo emulator tool, WES, that I was developing on the weekend. When last I left off, I was talking about using generic programming to do pretty printing of structures automatically. To give you an idea what that looks like, I have some example output here, and there's some public Flappy Bird Nintendo ROM, which I'm getting the information here. And the idea here, from a conceptual standpoint, is that this is a command of the executable that provides some uh, information about the Nintendo ROM. And in the case of a Nintendo ROM, that's composed of what the header information is, which describes the various properties of that cartridge. And in this case, we can see those properties are how many 16 kilobyte ROM chips there are, how many 8 kilobyte VROM chips there are, whether it's mirroring, battery backup, so on and so forth. And in this case, we're looking at a NES V1 file type header. And this printout here of this header structure is done via shapeless generic type class, which will generate a reasonable pretty printing of an arbitrary structure using generic programming. There is some custom output here, just so I can try mixing both generic programming generated output as well as some manually specified stuff. What I continued with was adding something I just call a block summary, where it gives me what I think is a convenient summary representation of some data. And in this case, it's supposed to look like a hex dump, but it isn't a hex dump. This is similarly visually, because that's what I'm used to looking at quickly, and it's always 64 hex words long. This is actually a hash of 256 byte chunks, each one of these hex words. So it doesn't give you a direct impression of what the contents are. It only gives you an impression of if two chunks are the same or if they are different. And already we can see here that we see a lot of chunks are the same. They have this hash representation D9876A9C. What that actual content is, I don't know, but we can see that there's quite a lot of similar stuff and repeating patterns for that one. I suspect this is probably just empty 0. This actually ends up being the hash representation 0. But anyways, it's always 8 by 8 because it's visually easy for me to look at if the total data being summarized is small enough, then it will be exactly the hex representations. The data structure that represents this summary of byte data is here, block summary. The actual data attributes aren't very interesting. It's a list of integers and a value that represents the chunk size. This list of integers is exactly the integers that are printed out in this hex representation. And like I mentioned, those are actually more just hash values, or if the data is small enough, exactly the data. Itself isn't interesting. What's more interesting is how it's constructed. This is using the scodec bits library to provide a byte vector, a pure immutable byte vector, and defines a constructor from that byte vector to one of these block summary instances. And here we see how the logic works out. In short, it pads it to a reasonable amount just to make sure it works well for the chunk size, then determines if it should do exactly the data in those integers stored in the block summary, or if it needs to chunk those and then do integer values for the hash of those chunks. And you can see that I'm just using hash code for the hash. It's not the appropriate hash to be used, whatever. But for this purpose, it's just fine, and it was easy to use from Scala Native. And then we have this pretty printing to the console for that data structure. And that's just responsible for outputting the address or the offset into that block we're summarizing in a nice bold with this hex representation. Speaking of console pretty printing, this is that type class and embedded DSL that I was referring to for pretty printing of the console. When I last left off, there was actually a bug. We're going to go over the bug to see how I ended up solving it. It ended up being an interesting adventure. The bug was involved in printing the header for the info structure. So the info structure was that summary structure that I want to see when I execute an info command of just the data. And here is the info structure that I'm interested in about an NES ROM. One, there are two properties or two attributes that are common to all info structures I would be interested in. Imagine if I expanded to different ROM for different systems. One is the description of the source, and the other is a header. Now, this header field has an interesting aspect to it. One, in the super type here, info, the type of source header is header. In the subclass here, NES, the type of header is refined to the NES v1 header, which is a type of header. This type refinement done from info to NES is rather useful. It ensures that all infos have this common source header, as well as enabling each different type to extend it with specifics for that system. Now, this caused a bit of problems because when we go to pretty print using the generic pretty printer, this info structure, it ends up it's unable to find the implicit that represents that generic pretty printing. This is the error from the console, from the Scala compiler directly. It doesn't really tell you much of anything of why it was unable to find this generic pretty printing. And this to me was a bit surprising because in my head I was considering, I have a pretty printer for strings, I have a pretty printer for headers, and I have a pretty printer for these other two structures. So it should be able to find a pretty printer for the product of them all, which is what the generic programming is supposed to enable us to do. How would we go about solving this problem? It ends up that you really have to turn on logging implicit resolution in the compiler. So we'll go ahead and do that, and then we'll request a compile again. And here it's now actually going to trace the implicit resolution process. It's going to do it for all implicit resolutions in the project, and there's quite a few more than we're interested in here. So I'm going to skip to here, which is really the start of the section that we're interested in. We see here the next error related to this is could not find implicit value for parameter fi, which the critical part is this type west.rom headers.nes v1, which is a subclass of the header type. This really is the key error in this reported output. This is a type within this project, and this is a type class within this project. So it's not referencing any other coproduct or HLS constructions that came from utilizing shapeless. It's just trying to find this one. And this is something that's easy to check. It's pretty easy to go, hey, there is no headers.nes v1 pretty printer for this. Kind of. Because if we go to our header companion object here, there is a pretty printer for the header type, and this will, when applied to an NES V1, pretty print that. So why wasn't that inferred for here? It's quite simply because it wasn't told in any way, shape, or form that that can be done. The easiest way to do so is to then make this pretty printer parameterized by any type that is a header, and thus when it goes to resolve a console pretty printing instance for this subclass of header, can find that directly. And sure enough, that compiles as expected. We no longer need this implicit resolution, and the easy way to undo it in SPT is to minus equals the option. Source code, as usual, is up on GitLab. Feel free to check it out. There's a few more things beyond this, but I thought those were the fun bits to go over. Until next time, later.